Right. It does look like we're live now. I'll confirm that. First, turn it down. Let's see. Just need to confirm that we're live and we're good to go. Okay. It looks like we are live now and good to go. Let me view this and confirm. Alright. Okay, good. So today I am working on a database migration tool for SurrealOrm, which is an ORM I've been building for some months now. And actually, it does support, even though it's an ORM, it's also a query builder, and it also supports writing raw query. So I'm working on a database. Oh, so it's quite nice because it supports a lot of things. So you can write raw queries that are going to be checked. You can use a query builder using like a builder pattern, and that works well also. And you can use like the ORM, so sort of like utility methods to do a lot of things. I can demo that later in the future, but today I'll be focusing on the database migration tooling that I'm creating for it. So first, let's clear this, clear that out, and so basically we're gonna create a new workspace member and perhaps call that migrator or migrator. I think that's a good name. So I'm working on the migration tooling. Let's call that migrator. That looks, should probably have created as a library, but that's fine. Let's come here and create a library. Migrator, let's add that to the workspace. As we go up here, we call that migrator. I'm going to increase the font size now. So you guys can see what I'm working on. My editor is messing up. Anyway, let's see if I need to exit. Update. I hope it doesn't freeze. Alright, that looks good. So I added that as a workspace member. So we have migrator, and what else? Let's go to it. I'm just gonna add this here also. We'll call that migrator and migrator. Maybe move that down a little bit. I don't know. So we're gonna come here and just create a function called that function migrator and just print migrator, right? So let's see how we're doing there. We should be able to call use create migrate. Actually, is that made public? No. Public. So let's use migrator. Let's call that migrate rather, just to see that things are working. Migrate. and we can of course call migrate here. So that's the initial setup for this. So what I'm doing is building a database migration tool, and what we want to achieve actually, if we come here first, let me make a description. So typically when we have a struct, let me see if I've got one here, weapon, or let's use rocket. Rocket is an object. Let's use spaceship, maybe. Or I'm just trying to find a user. Is that a good example? Or planet? Let's see. Okay, maybe we could use planet. Yeah, let's take that here. So essentially, let's say we have something like this. We're free to delete all this. Delete that and comment it out. So we've got something like this. We have your struct with all the definitions, right? From this, we're able to generate, because I have built these derived macros around this, we're able to generate a lot of stuff. So from this, we're able to call, let's say, planet get schema or something like that, and this could give you like a vector or something like I don't know, define. For the fields, it could give you define field, ID, type, what would that be? Let's just say type string or type ID, whatever, for now. Then you could have something else for name, define field name, type string, right? So you're gonna get something like this. Remove that, and we have, let's say, population, that is type integer, and you have created that, and that's type datetime, right? You also have tags. So tags would be actually an array of integer here. So you could have something like this generated for you automatically, because I've implemented a bunch of stuff using this node attributes, this right here, right? From this we can generate a lot of information, right? And it also automatically derives the type. If it's not able to guess what the type is, then you might have to do something like I don't know, SurrealOrm, maybe type string. If it's not able to detect it, it's gonna tell you that it's not able to detect it, so you don't have to worry about it. If it's not able to detect it, you're gonna know, it's gonna alert you. So for now, we're just gonna take that out as integer. So we're able to get this information. Something else we're able to get is table definition. So from this, it's gonna be like maybe get table name, get table def, right? So table definition can give you something like define table planet. And if you have more complex stuff like permissions, you could also have like permissions, right? Assertions, etc. For the fields also, actually, you can, for each of the fields, if we go here, you can also have permissions, assertions, and whatnot, and that is also going to be included for each of them. But for now, let's just deal with something simple. So here we're going to, with this in mind, we want to do a bunch of stuff to do. So we want to what would be extract schema from structs, and extracting schema from struct includes getting fields, schema definition, then also get table schema definitions, and this includes the permissions and all this other stuff, right? So we're gonna do that first. Something else we need to do is so this will give us the existing metadata definition from our code base. Then we also want to get or field definitions from migration directory. So we're gonna create a directory. Maybe we should have that first. Get all table. Then don't forget, in addition to the fields, we also have, so we have for fields, we have for table, then we have, let's put those two first. We also have events. Event could be attached to a table, right? So we're gonna have define event blah 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 blah, right? Then what else do we typically have to index? So let's say indexes or indices, whatever you want to call it. Define index, right? We'll be able to generate all these things from our table definition. So we have this, all this stuff, and so we want to get field definitions. We want to get basically all the definitions, but that includes the fields, events, and also indexes, right? So we're gonna get that from our migrations directory. Okay, we extract this from the structs, and also we're gonna do the same events and indexes. So this will all come from like the migration directory, right? So we have that, which is good. So first we also need to create a migration directory with either both up, down migration, or just up. So yeah, it means it can be optional, but anyway, migration file format would be, let's say, we can name it, oh well, thanks, timestamp name, and I'm thinking we could probably something else we could do is maybe do like direction. So an example would be, yeah, thank you. Maybe this isn't the kind of timestamp we want to use, like let's just remove this. Let's say 1 2 4 5 6, right? Something like that. That's easier to deal with. We want to use, like, I guess that's time, seconds elapsed since the epoch 1970 or something, or whatever. So we're going to create a directory with this. So this would be under migrations / this. So there are two options we could use. We could we could do migration slash migration name, then the up or down, like the direction. But I tend to like flat structure because it's just easier to skim through every directory without having to open all the subdirectories. So we could try to keep a flat hierarchy. So that's some of the stuff we need to do. What else do we need to do? Create a migration table in the database with fields, migration name, direction status. Let's keep that for now. Migration name, direction status. Okay. Then what else do we want to do? We want to implement different functionalities. So we want to be able to run the migrations. So we want to be able to first also create migration table, and I don't know, we can have that. Nah. We want to be able to get all migration names from the database. So we could have something like thank you. We could have something like that, right? We can get all the migrations. We also want to get from the directory, and yeah, thank you. Run the one that I know in the database, yeah. Then update table with the new this. So we want to be able to get all the migrations from the database. Then get the ones from the migrations directory. Then we do a comparison and get the diff, and then run the migrations that are not in the database, and of course we want to add that. So basically adding that would look like marking migration as registered. Then we also want to support like support like rolling back. And how would that look like? We want to be able to mark migration as rollback or unregistered, as unregistered, i.e. rollback, right? So we want to support rolling back, and there will be different kind of changes. There will be, let's say, change types, right? We have field let's remove field, change field type, then add table, remove table, add events, remove events, add index, remove index. So we won't have add assertions. So actually what I'm gonna do is, so for these changes we have for fields, actually what I'm gonna do is we're gonna have add, remove, and change. So if the name stays the same but the type or something changes, right, then we're just going to basically keep the field and just apply the new one. So if previous, is define field ID type. Let's maybe do name. Maybe name isn't this the best stuff. Age, right? And you change the type from integer to, let's say, int. Okay, that was int to float. From integer to float, then next could be new. Yeah, so we just need to apply the new one. For this we need to onset field or set field as null to delete the field. Then for adding field, yeah, just define the field. But another thing is, yeah, so changing field name, for example, this is a bit more complex than it might seem. Let's keep that. So this is a little bit more complex, because we need to create a field with a new name, copy the data. So when you're using Rust, I think especially when you're using Rust here, I think there is very little reason for you to rename a field in your database, because if you're using something like Survey, you can always just use Survey rename, and that would work for anything you want to do, right? So you almost don't have to rename it, but you want to assume that people want to rename stuff, right? So of course, renaming is a little bit trickier if you're trying to do this in an automated fashion, because how are you able to tell if a field has been renamed, or it's just like you've deleted a field and you're creating a new field entirely, right? So those are the things we need to take into consideration. I mean, you can use some heuristics and say, let's say you've got 5 fields and suddenly you've got a change in one of the fields. Let's say the name is renamed, but you don't have a new field or less, so you still in the diff, in the new change delta, you still have 5 fields, but one of the attributes of it and one of those fields has changed, like the name has changed rather. Then you can assume that one field that was here previously but not here, you can sort of do like a right diff, right? And from that right difference, you can tell that this field was renamed, right? But what if a user actually wants the new renamed field to be a new field, and they've just deleted this field, they want to start afresh, they're not trying to move the data from the old field to the new field. And right now, at least SurrealDB, as far as I know, as far as I'm aware of, doesn't natively support like alter, like renaming a field name. So that is going to be a little bit interesting, and we might have to come up with a smart way to undo that. And I can maybe go search through the code base to be sure that it still doesn't support it. So I'm just gonna confirm. I'm gonna confirm that SurrealDB doesn't support changing table name natively, but at least we can make provision for that already, even if it doesn't support it already. But let's see. Yep. um, it doesn't support that yet, so which means that we need to come up with a way to handle that. But in the meantime, we can just note that it's a bit more complex. So we need to create a new field and copy the data, and we can delete the old field. We can also rename the field instructs. No, anyway, we need the main thing we need to do here. Main thing we need to do. Main thing to do is to reliably detect a field change, field name change, and undo the change, the change, the data change and migration. So how do we reliably detect? How do we reliably detect a name change? We have different strategies that I've been contemplating on. Strategies, I'm going to note the strategies that I was thinking through this morning. That's not that simple, because if you create a new field, then what about the data? Are you just going to delete the entire data? So if you have a struct, let's say you've got a struct planet, one of the strategies I'm contemplating on is so I had an example whereby you have age. Let's say you want to rename, you're looking to rename this is the old version, right? And you want to create a new version with the name change to, let's say, first name. So now this is going to be first name, right? So how do you detect? So there's a diff now, and the diff here, right? If you look at this, so you have a diff first name to right name, right? So if you think about it, on the left, you have let's say you have name, and on the right you have first name. But how do you tell that you've not just deleted first name and add a new field? In which case, you don't want to transfer the data from name. You want to just remove that entire field. You want to delete all the data. But if you're trying to just alter the name, you want to be able to migrate the old data, right? So how do we tell that? So one strategy that came to mind is, I could, since I'm already creating a derived macro, I could do something like old name, right? So I'll also discuss the trade-off. So let's say you could do something like this, old name, right? And do this. So when the macro is running, we're able to say, okay, there's an old name here. Then we do sort of like transformation, right? And I might even be able to create some compile time check to see if name previously existed. I believe that might be possible. That might involve reading the migration directory, maybe not that necessary. But this is a strategy that I've been contemplating on. You could use this. The trade-off with this is, when do you determine to remove this? So one thing could be, maybe after you're done running that migration, you can remove this. But the problem is, people can always forget to remove these attributes, since it's not like you're done running the migration, right? But it really does no harm. You can always have that here, right? So if you're gonna use a strategy, we first need to check that first name doesn't yet exist. If first name already exists, right, then we know that this transformation has already taking place. We've done this transformation in the past. We don't need to do it again, right? So we need to first, let me note that if using this strategy, and we can also combine strategies. If using this strategy, we need to first confirm that the transformation or change had not already previously been done. We can do this by checking the database schema for the new field name. If it exists, then we can skip the migration. Yeah. So we can do this exactly, like we can just run through it. That's one strategy. Another strategy is, do I have migration? Okay, let's name this strategies, and this is strategy one, right? And let's come down here, and here we have like strategy 2. So in strategy 2, prompt user when you detect a potential field name change. Field name change. So basically this could come in the form of anytime you see an addition or removal or just a name change, right? You can prompt a user and ask which of these fields has been renamed, right? So this, I would say, detect the potential field name, especially when there is a removal. Would that be right? No, maybe not a removal. When there is an addition and removal at the same time. Yeah, at the same time. That could be one way to look at it. Alright, so I'm going to have the second strategy. Another strategy is you could have it as part of the metadata when you're building this. But anyway, we have that down. I believe we can probably start implementing something, right? So the first thing, let's second. I made some notes and I'm just looking through my notes. Yes, so some things we want to implement is, let's say, generate migration, right? And let's just do that. Then we also want, let's see, apply migration. We'll probably create a trait and stuff for this later, but let's keep it simple first. So we need those two. I just basically applies the migrations we might not have applied yet. So those are the two main stuff first. Then we need to be able to create the directory with the timestamp and the name, and also we need to be able to roll back migration. Then we also need to be able to run migrations. So let's run migrations, then roll back just a migration. Yep. So we have that, and let's see, I'm just trying not to forget an important point. All right, we need to create, let's say, database. This will have like, let's say, like database connection, could be connection, could be a better name. All right, so we're just going to put like the connection details, and yeah, then some important thing we want here is actually that's an implementation detail, database connection. Some things we want here is be able to get current schema. So basically this looks at the running database, right, and gets the schema for the table, for a specific table. So we can do like self, then we have like table name string, right, and here we want to, let's just return a hash map first, right, a hash map. And actually we're probably not going to be using a hash map because at least currently Surreal schema, this is how it looks like. It has events, which is a hash map, string, then indexes and tables, and also fields. Yeah, so when you do, this is the query. Let's just have a pseudo code for that. So you have something like db query info for table. So in this case it will be table name, right? Then let's say this returns Surreal schema, and let's just derive default Surreal. So this is what we're gonna use here to get the current schema for a specific table. and from there we can get a fields definition, we can get table definition, but obviously I need to be sure what the tables return, because we're getting information for the table. I don't know if it's returning reference to some stuff and blah blah blah. So that's that. Then let's create another method called, let's see, execute, and that just takes self and query. Let's just do that for now, and let's just print executing query. Then we also want to get all the migrations that have been applied to the database, right? And oh, it's get all get applied migrations. I would use that. So that selects by the name, and here we would be getting something like, let's say, to what's today's date, 2023, and however we want this timestamp, and let's say this is add name, right? Then this would be remove 2023-09, remove name, right? And actually this could be up, down, so we could have something like that. Expecting string, yeah, I guess so. We can just so we could have that. This is like a mock data. You'd run the query against the database to do that, right? Then we want to be able to actually create the particular migration in the table. So not necessarily apply migration, but this would be, let's say, mark migration as applied. So you're not necessarily applying this, you're just basically creating migration in the table. I don't know if that makes sense. We can use the ORM here, but that's what it's doing, but I prefer the name. So we can just say create migrations. I mean, since it's SurrealDB, we can actually do something like create migration with the name, migration name. That would be the ID. So it could be with the timestamp and stuff. So we could use the ID as the name, and we could use like contents, right? Content would be name, migration name, something like that. Then it's going to execute this, right? So we can call self executes whatever the query is. Let's say query format. Yeah, I'm gonna change all this. I'm just trying to more so like writing pseudocode. So then we also want to do the support the reverse, so marking it as rollback. So rollback would be on mark, let's say migration. That could be as simple as that, and just call that on mark migration. Yeah, right. So because this is only marking it, it's not actually doing like it's not rolling it back, it's just saying we're deleting it from the table, right? So we can just, it's very easy to do this in SurrealDB. You could use two strategies. You could just say delete this and you're good to go. Alternatively, you could have delete migration where name equals migration name, right? So we can just comment that use either of the two. But for us to be able to use this first one, then we need to make the ID the migration name, right? So this would then do a marking of migration. So unmark migration. Ooh, so we'll delete that. Okay. So what else do we have? We have the main functionality for, like, you can, of course I've not really implemented the main thing. This is just to give a general idea of what we're trying to achieve. But then we have the migration itself, and for the migration we could have up or down. So there are different ways we can define the migration struct. So it could be migration. Let's see. I was thinking we could have up, down. Direction. So one way we could do this is we could do up, and that could be this. Then we also have down, right? Right? Or since we can seldom have a situation where this is optional, and I'm not sure, I'm just thinking if we should have something like in direction. We have up with string, and we have down. So this would be up, down, or bidirectional, right? Then this would be one way. So we could have one way, which is just up, and as a matter of fact, let's see, in direction. One bidirectional, or it could be one way. So this is one way we could model this, but this can get cumbersome when we're actually working with this in practice, right? I mean, we can create some helper functions to maybe make it a bit easier, but it's still a bit cumbersome. Alternative we could have is direction. Let's call this direction 2. So we could just say bidirectional and up, down, and we could have one way, just string, which is also, like, I think this is probably a better way. Or we could do the same if we want it, just up, just to have that consistency, right? So I don't know, the second one seems easier to manage. So let's try that first. Direction right. So we could have this definition for migration with both up, down, or like, and I mean we could have some helper functions like is bidirectional. Okay, bidirectional, bidirectional, or it's two-way. Oh, bidirectional. It should be bidirectional. Bidirectional. Or we could say two-way. Yeah, I think let's keep the grammar simple. Two-way, one-way. Yeah, that's probably easier to grasp. And we could use just a simpler way to do this. So yeah, that's a simpler way to undo that. Is, so let's change that also, is two-way, and yeah, we could have is one way. Yep. So we have those two helper methods just to make it easy to deal with this. So those are for the migrations from migration directory. Yeah, great, awesome. Then the next thing we want to do is be able to get the migration from the directory, right? And we also want to be able to get migrations from the table. So we get from the table, and we also get from the directory. I'm contemplating if I should make it as part of, if I should make it a method, but let's make it normal. So this, let's say the first one is get all migration from directory, right? So we could have something like this. Then we also want to maybe get a particular migration, right? So we call that get migration from directory by name from there. So we then provide the name, and yeah, this could this is one way we can handle it. Get ready file. But we probably want to just take the name and maybe just let's return a fake data for now, right? But we probably just want to get the name, and we can go to the directory and get that specific file instead of reading everything. I think it's inefficient for us to have to read everything just to get the name. Then we want to run the migrations and want to roll back. So these are different from marking the registration as migrated or unmigrated, right? So for this, we want to have something like this. Let's call this like run migrations, and this will take our database. Let's say so we get applied migrations. So dp get applied migrations. Oh, did I already define run migrations? Oh, interesting. Yeah. Okay. So it's gonna get the applied migrations, then also we'll get the run migrations. So basically this will give us like, do we even need that? So now I think let's go here. Yeah, so we get all migrations. Get applied migrations from DB. Let's make it more descriptive. And this is from directory, right? So we basically just want to look through and do like a diff. So something like, it will go through all the migrations. Okay. If it's two-way, migrations are not supported. That's not true. But if it's one way, then so we'll probably get we need to decide if we want to detect if it's one way or two way, or allow a user to specify that as an argument from the command line, right? We need to deal with that. So if it's two-way, then we want to actually we also want to do the same. So it doesn't really matter if it's one way or two-way, but it doesn't matter, right? If you're running the migrations, then it shouldn't matter. So we can comment this out. Let's see. Oh, we need to get up. Okay, so what we can do is, since we have direction, okay, I know what to do. So we can create a method called get up migrations. Search. Let's call that get up migration. Actually, why don't I tweet about my stream? Guys, like if you're watching, and share. Streaming my database migration implementation for let's share that. Let's share it on my personal also. Good. I think we have get up migration. So this should return string, right? And why do we have to go on there? Okay, I wonder if we could just, okay. Anyway, let's do that first. So we do get up migration. Yeah, so we have that. I think the direction doesn't matter when you're applying, right? We can revisit the thought process there later on. What we want to check is we look at all the migrations we've applied in the database, right? And we are seeing we probably want to use that as a hash map, but anyway, we get all the database, the migrations in the database, and we get all the ones within the migration directory, which is sort of like the source of truth, so to speak, right? So that's like the source of truth. And then we check if the ones we've applied in the database, right, if it's basically if it doesn't have the ones from the directory, and if it's not, then we basically execute the up migrations, because now we are applying migrations in this direction, right? Then we mark it as applied. Marking as applied is basically we add to the migration table saying that this is a data this is a migration that has been applied. Then we do the same thing for rollback, and typically there are two ways I have seen rollback being done. So you can specify a specific data migration you want to roll back. Typically it would be the latest one, right? But also you can have like a delta, roll back the last two. And you could also have like, if you specify one, I expect that I should roll back from the latest to the earliest. So what we're gonna do is we're gonna do rollback migration and specific. So basically this gets all the migrations from the database by name. Then it executes this one would be a little bit interesting, because here we actually want to execute the down migration, right? We want to execute the down migration. So I'll create a down migration, which should be, because it's possible for it not to have it, right? Get up, get down migration. this. Roll back. Okay, let's comment this out. So for anyone just joining, I'm working on a database migration for SurrealOrm, which is an ORM I've been working on for months. Maybe I've been working on it for like 10 months now, and I'm quite excited. I'm gonna show you what I'm working on. So you're just joining, this is what I'm working on, SurrealOrm. Check it out, it's already public. I haven't published the first version yet, but you can already see the progress on my GitHub page, right? So feel free to join. I just released this yesterday also. Trust, if you're using Tailwind macro, this is good. Like, you can check your Tailwind macro classes at compile time, so check this out also. But right now I'm working on SurrealOrm. Alright, let's proceed. So that's rollback. We get the down migration and then we execute the down migration. Let's do that. We execute the down migration and maybe we can do this down migration because I'm going to execute down migration, else we can throw an error. We could probably panic here and say no, down migration doesn't exist. Let's just print that. Yeah, we can say something like, yeah, or cannot roll back migration. Right, perfect. So now we have like the pseudocode for most of the things that we need. Let's see if there is something else that might be important. I think we pretty much have everything I was thinking about adding. So we have the main functionalities. Yeah, I'm just going to create initial base migrator functionality, migrator raw idea. Yep. So we've got that, and what else do we need now? I think we can probably start implementing some of these in the actual sense. So let's start from the first one here. We need to get the metadata from a struct, like a node or like a model, and that gives us all the field definitions. We need to get the table definitions. We also get that from the struct. So I'm working on a database migration tool. We need to get the events that comes from the struct. We need to get the indexes that also come from the struct, right? And what else? We need to get the field definitions. All this comes from the struct. Then from that, we are going to be creating migration files in migration directory. So we'll create a directory called migrations in the root directory, and that will follow this pattern: timestamp, direction, name, right? So you could have the timestamp up and like create planet, and this should be delete planet, right? So from the directory we should be able to get all these information, basically all the migrations. Then we need to be able to mark a migration as registered. When we apply a migration to a database, then we need to add it to migration table, right? Let's call it migration. Then also we need to be able to get all the migrations names from the database. We also need to be able to get all the migrations from a directory. Then we can compare the two and get the difference. We run the migrations that are not yet in the database, and we basically mark every migration that is in the table as applied, right? So what else do we have here? We're going to deal with all these things one by one: adding field, detecting an addition, detecting a removal, and detecting a change. And for detecting a change, that's a little bit more complex, and there are like different strategies which I've listed here. So you can tell the user to specify like an attribute and say this is an old name. When I'm renaming this field from name to first name, you can specify old name as an attribute, and you specify this. The second strategy is that you prompt a user based on a heuristic. Anytime there is like an addition or a removal of a field at the same time, then you can ask the user, did you rename this field? Like any field that has been removed, did you rename it to one of these? And then the user can say yes or no. We can combine both of these to get a better robustness, right? So let's see. You probably don't need any of these anymore. Yeah, I can safely remove that. So we have the database, get current schema, mark migration as applied, get all migrations from the database, then unmark migration. Then we also have the migration itself, mainly from the directory. So we can get a migration, we can get a specific migration. Then we can run migrations. So we get all the migrations from the directory, we get the ones from the DB, and see if it has been applied. If it has not been applied, then we just execute the up migrations and we mark it as applied. Marking as applied just means adding it to the table. Then we can also like roll back migration. So some things that came to mind is, let's see, it would be nice to reuse some of the toolings that I've created previously. We don't need this. So we want to use like dog food, our own stuff basically. Yeah, I could import SurrealOrm. Yeah, so I could mark that as a dependency. Let's go. I could mark that as a dependency or just import things directly from Surreal derive to prevent dependency cycle, but let's try it first. Do we have SurrealOrm as yep. So we can use SurrealOrm. Yeah, we have all these functions that I've created. We can do a whole bunch of stuff. There's a lot of things I've created here. As you can see, there's a lot of them. And of course we have the query functions, and you can just do like crazy stuff. We have the node. So we're going to so for example, yeah, I mean we could just write this query raw. I don't think it's that big of a deal. One other stuff we want to have here is actually SurrealDB itself, right? So we want to have SurrealDB and Rust Analyzer is freezing my stuff. It's loading SurrealDB from the workspace. If you're just joining in, I'm working on a database migration tool that's going to be doing everything in an automated fashion. So we have SurrealDB, we have SurrealOrm, then we can go here and we can so again information for table is gonna give us, let's see, I believe I have something like that, info for table, then we just need to pass table name into, right, and not build it, we need to run and pass the database. So I will check one of these. Let's go to one of the examples. actually test. $26. So let's take that. So this is one thing we can do. We can pass the DB around as an argument, or we could use it like lazy or one cell. Let me see. I'm trying to see. Let's check that out. So we can just specify this here. Let's comment that out. Input that, and so we're using in memory for now. So this has to be an async function now. It has to be an async function, and we might actually need a sync trait. So I'm not sure if we have this. Let's see. Do we have a sync trait? Oh yeah, we do. Workspace. Alright, let's see. It's loading the sync trait. Oh, this is not a trait, it's a function. It's just a mere implementation block, so we're good, I guess. run Surreal schema. I need to document this method. Okay, always. Okay, we may need Saturday also. It's loading Saturday. Saturday. Is it downloading now? Yep. All right. So what do we have here? So we have serialize and deserialize. Okay, so this has to be an option. Okay, current schema. So this has to be an option. I guess. Okay, we're gonna come back to that. Fail to take schema value. Expect fail to yeah. Let me see you good though. Do we even need that? Ooh-wee. Okay. Expect a semicolon where and why. Oh, I see. Okay. So that's one way. I mean, we could just do this db.query and info for table, then I don't know, table, then bind blah 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 blah. You get the gist. Bind table name. Then you have to do type table. You get the gist. But I'm not about to do that. I'm not about to start stressing myself, and that's why I've created this arm. It's so I don't have to do that. That's the whole point. It's so that I get the freedom not to do it. Why is it expecting semicolon though? Oh, I see. Of course. Yeah, let's just chain. Let's just do some chaining, brother. So I might actually have to. Do I have like get or return? I need to do that. I need to implement it for others also. Like just like get, so you don't have to do that all over again. I think. Should I just do it now? Should I or should I not? So I could do like get or get one. Maybe later. Should I do it now? Should I do it? Should I? Get missing get data. I don't know. Run it out. This should be option self, and that would be, we could basically just copy that, right? So this could be self, Yeah. Mismatch type. Serialize. Okay, let's break it down. Response. Couldn't convert. But this should work, right? What? Oh, can I convert from option to? That's interesting. Does this return option or results? Oh please. My ID is messing up again. Okay, good. So let's try that. Let's see what we've got. Oh yeah, it returns. Oh yeah, I think I get it. We need to, of course, since we're using that, we need to let's try to unwrap it first. So that works. Response. Mute. Good. However, I would still like to. So this returns results. I will still want to do this. And if you can't convert that, maybe we need to map the error then. Map the error and to SurrealOrm error. And maybe this deserialization. Yep. And with that we could probably do something like this. Right? Just call this returns the deserialized results. So with these we might be able to simplify that. So let's get data, right? Then let's move this all out and get data. Surreal schema. Let's just wrap these. Let's double wrap this. That should be improved. Also, let's take 0. That's interesting. Let's go back. Oh no, we're not using the self because the reason we shouldn't use self is we're not referring to the query, rather we're referring to the data. So we could probably do something like this, option T, or I'll call it T data or whatever. Then yeah, yep. So does it make sense to return result of an option or just return a result? That's a question we need to ask if that's how we want to operate, right? So we just have to ask if that makes sense, but we can come back to that later. But for now, I'm just going to return a result of an option because there are like two phases. The first is you run the query against the database, which is a fallible operation. It means it can fail, right? Then the second is you have like a deserialization process, which can also like fail, right? I guess we can coalesce both and say the serialization process we assume would be part of the query running process, right? So that's something we just have to decide by ourselves. And in my opinion, I think the deserialization process should return a result also and not an option because it could fail, and if it succeeds it's probably not going to be returning none, it's going to be returning an error, right? If you're not able to deserialize it. But for now I'll just leave this way. We can come back to improve it. Do we even need this anymore? Execute query. Or if we're using our arm, we may not need this anymore, right? Yeah, we might not need this anymore. So this gets all the migrations also from the table, and the way we're gonna do this is let's use select statement. Let's say migration names would be select. Actually, it's do we want to make this okay? Derive, we derive node, serialize, deserialize, and maybe we don't need that. Table name always be provided. I'll actually still make that optional, but for now we're just gonna add that. This is a nice thing. You see that there's a lot of error handling. Now it's telling me that you have to follow the convention, so it has to be migrations rather than migrations, right? So now I believe that should be fixed. I think my ID migration try. Yep, yep. Yeah, I need to. My editor is freezing now. Ooh. Okay, that's weird. Yep. Let's go. It's still acting up. Maybe not that. Let me quit and restart this. Migrator. Let's reload, fellas. Oh, I've been working on this for 10 months straight up. It's quite interesting. It's quite interesting. But in faces though. So awesome. We got select name. So we could do that. Migrations. Migration. No. Migration. Schema. Name. Migration. Table name. Migration. So these I think I'm gonna make that into a method and call that, or I could have it also as a static method. Well, let's just do get DB, get database itself. So DB So we can do this. Get DB. Yep. Good. Select, then we want to run, let's say return many, self.getDB. Right. Yeah, we could just, I guess, return string. Right. We need to wait. Let's unwrap first. So this gives us a vector. However, there is one thing to note: when you're doing this selection, you're selecting the field. What you actually want, if you're returning a lot of stuff, you want to select, I believe, only that if you want a single object, but this should actually be select value, if I'm not mistaken, and we can test it. Yeah, let's try out some stuff. Okay, so I don't know, what do we have here? Let's see. Okay, movie, what's on tab 2? Okay, let's create different users. Oh, it's still loading. Okay, let's create the first user. Let's create another user. Let's call this what's happening? Anyway, the whole point is that you use when you just do select, SurrealDB, I believe, would return this as this. If you just do select, it will return this. Let's say, right? It's returning an object still. You use select only when you want it to return a single object, like name, hello. That is when you select only. This is when you select value. No, this is normal select. Select only should give you one object, so just one object, right? And then select value should give you the specific. So in this case, it should give you just the strings. So you want to use select value in this case, right? If you understand what I mean. If we use just select, it's gonna give us still an object. It's not gonna give us an individual item, and we want the names alone, and that's why we're doing this, right? So this gives us the value, but still I'm gonna leave this I guess. Okay, let me take that out. I'll just put here migration names. What else do we have on markers applied? So to do that, we just want to create the migration. And this is where it gets interesting, because here now we've got the migration. Migration course create create contents. Oh, I think I might have also created migration dot create. Do I have that? Don't I? I thought I would have. Oh, I'm actually quite surprised. Clean this out. So create. Yeah, we can use save. Let's see. I'm thinking. Yeah, there has to be an ID, right? Sorry, ID string. I probably have to give a warning. Anytime you forget to include an ID field, I think I need to do that. Let me put it in it to do. One when and if you not included so actually ID would just be migration create ID. That's great. Good one. Yeah, that's right. Oh, I need to wait and unwrap that. So what do we get now? Is that possible? Great. Create the first one. Create content. Yeah, we were here. This should return. Yeah, I believe this should return. I might have to restart my editor. This should return migration. Immediately to type on the title. Are you doing this without Googling? You made a little typo in the title. What was the typo? Oh, thanks. I need to check that. Let me see if I can fix that. Yeah. Are you doing this without googling? Oh, thanks. Thanks. I'll fix that now. Yeah, I mostly already have an idea what I want this to do. Have a clear picture, I would say. To do. Thanks for joining. Where are you chatting from? Yeah, I need to fix the title. I'll see if I can do it now. I'm not sure it's possible. Manage videos. Okay. I'll see if I can fix that after the streaming. But thanks for calling that out. Yeah, so I'm just mostly building this. I sort of know what I want to achieve with this, and I just need to write out the code. And I've been working on this for, the ORM, I've been working on it for 8 months, so I have quite a clear picture of what I want this to do. Although a lot of the ideas that I'm using here are quite new that you may not find in other places. So I'm just trying to see how far I can get, just looking at things from first principles with fresh face. So we'll see if I'm gonna fail or succeed. But yeah, so I've already built the ORM pretty much. It's complete. I can show you if you actually go to, let me see, if you go to this repo, it's still ongoing. You'll see a lot of examples. If you go to this test, for example, you'd see a lot of examples, right? So you can do almost anything the database can do itself. You can do with this. You can work with geometry. You can do a bunch of stuff. You can work with line string. You can even do, like, let me show you some interesting stuff that you might find cool. This is one. I think this is also quite interesting. You can do if else. You can even do some complex transaction. I think those are quite interesting. I could also show you some stuff in update. Let's see. So you could write a raw query, and this is going to be checked. So if you make a typo, this is actually going to be checked at compile time without you running your code. So this is one of those things. When you're doing like relate also, you can write your relate query this way. So you're basically saying relate students with ID, student ID 1 with, and write book. And the nice thing about this is this dunder, like double underscore, goes to the direction of the arrow. So I just added this stuff to give it like a clear picture, so you know this is going to the right, like this is an outer connection, right? Writes book of this ID, right? Then you set the content and you say parallel. And I have a concept called loaders. So for example, here you can specify the field you want to load. You can say just load any link. So a link is just a foreign link to a table. So by default you get the ID. But if you want the full object from the foreign table, you can just say load all links. You can say load link once. You can say load link many. There are a bunch of stuff also. Yeah, we're using the setter method, and the interesting thing about this is actually these at compile time make sure that you're using the right type. So when you're doing time routine, you cannot put string here or like a number. You have to put actual duration in it. So there are lots of interesting stuff here. I think you can go on and on and on. You can even do like complex stuff, more complex stuff. So you can relate a statement to another statement. So this is a statement to a statement, and that works. A bunch of other stuff here also. Then let me show you. If else is also interesting. So you can write your if, you put the expression, but the nice thing here is you have to start with if before you go to else if, and else if before you can go to else. And for transaction also, you can write like complex transactions like this, and all these things are checked at compile time. I'll do a crash course once I'm done with this. I'm trying to just finish with the whole thing first. So the next one I'm trying to conquer now is okay, db execute, get migration. I guess we can do, actually this is gonna come in handy. So we can say db or self.getDB.query, right? And then we can just run. Maybe I'll wait. So mark that as applied. Apply migration. Create. Let's see. Then on mark, we just need to delete that, and doing that is just stays. So we can call delete. We can call delete migration create ID, migration name, just run that. Then we can say migration unmarked. Yep, so that's unmarks migration. This marks it's two-way, it's one way. Get all migrations from there. Then we need to be able to create migration also. So I guess I'm going to implement the getting migration from directory. Let's say we can create that as what's the format? Directory. So this is what we're trying to do now, and we'll create a timestamp and the name. Do I have create migration? Actually, let's check. Create migration. Create migration. So I guess we need to extract migration, extract schema from models. Yeah, we need that also. So once we extract schema, yeah, we need to be able to extract schema from all our models. So for example, if we create, let's see, planets, we should be able to do something like planet, that's schema. Yeah, and that should give us, I don't know why this returns unknown, but this should give us information. Let's see. I'm gonna close this again. Actually, I know what to do. Migrator. Yeah, it's probably work better now. It's indexing the dependencies. The code base. So we need to extract all those data from the models themselves, and my code is loading. So there's something I actually want to show. So we're gonna also have, like, we have the migration files in migration directory. Then we also have the current schema in code base, and we have current schema in database, of course. So in order to generate the file in the migration directories, we need to compare what we have currently with what we have in the code base, right? Yep, so it's done. I'd like this stuff to load fully. Why does it take forever? So we have that, and what else? So let's create migration file, and Yeah, we want to create it in this format. Where was it again? So we need a timestamp, we need a direction. I guess this could take direction. And name. So you can say path would be format. We have migration. Thank you. What about the timestamp? Let's use maybe chrono. Do I have that? I think no. Why is my stuff so messed up? It wouldn't even load. So anyway, we get a timestamp and yeah, we create a file at the path. Wow, took forever to load. Damn. Wow. Still loading. But anyway, so we get a timestamp and then we change Yeah, I know React Native. Do you want me to do something on React Native? I have a bunch of stuff coming up. I'll be doing some other stuff on React and React Native, and but lately I've been working a lot with Rust, you know, and I actually, quite interestingly, I actually started mostly with doing a lot of Python, React, and other stuff, but now I'm mostly writing Rust, and I can see myself doing some more React Native stuff in the future. So, but this is what I'm doing mostly for now. I guess we can so we can just use this random timestamp for now, or we can also use in year, month, day, hour, minutes, and seconds. So great. Thank you. Year, Monday, hour, millisecond. Then we have to create a directory, and we have to get a name. So let's create directory migration. Then what else? We'll get name, which we already have. Then we'll create the file at that part, right? Then we'll write the migration into it. So we can create a file, a path, and what else? Create the file path, and then we need to, let's put hello world first there. Then I can, yeah. So anyway, direction. Anyway, query. Yeah, maybe something like that. Yeah, so we're gonna have something like this to create a migration file. Then for the changes, we would have to detect it if it's you're adding field, you're removing, or you're renaming field. It has to be one of these three. Delete, add, let's use remove or rename. What else could it be? So when you're adding field, do I need to add this metadata? Name, definition, yeah, probably don't need more than that. Yeah, it's good. Then we need to figure out how to detect that. Detection. When a new field exists and it could be personal in a database, yeah. Exists in the database but not in the code base. Not necessarily, because you're not able to tell. We use the complex approach here. Detection. Strategies. Mentioned earlier. Create Yeah, so that's how we create the migration file. We have to detect the changes, so we have queries to run vector of string. to probably take a short break. Let's see. Back. Let's see if we can still get some more done. I probably have to take some break and maybe continue this later today. But first, let's see what we can do. So, one thing we need to do, we have to figure out if we can do some introspection, go through the code base and figure out which are the valid models. By models I mean nodes and edges. An example of a node is planet. I just showed you here. Planet is a node. Visit can be an edge. So we go through the code base and we sort of extract all the structs and we call the method schema or get schema or get database definition or whatever it is I'm using. And we aggregate, we accumulate all those, and that's the way we get the queries currently in our database. Then how do we get the queries to run? Well, let's first focus on two things, the table definitions and also the field definitions. Right. So for the table definition, we probably have to run the, 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 the current migrations in the migration directly, we need to run that against the database sequentially. So from the beginning up to the end, right? That's one way. And we don't even have to run it against the live database. We can just run it against like an in-memory database within that context. So we run all these queries, and that gives us the up-to-date state from the perspective of what we have in the migration directory. And after we're done with that, we can start doing get the current schema from this table, and then compare this table schema against the equivalent that we have in our code base, right? So if it's like planet table, we look at from the up-to-date database state, we look at the schema of the planet table, we compare for the table, has anything changed? If anything has changed, we just basically create a new query with the full definition. I don't think we need to go granular. If you've added like an assertion or a new permission or a new field or a new type, let's say it's like permission for creating for that table, we don't need to do for that specific. We can just take the entire thing. This is the simplest approach we can go. We take the entire new definition for the table and just take it along with us. Then we go for the fields, and we note the field that are being removed by diffing. So we compare from what we have in our struct currently and what we have in the database. We compare the two. We can tell what has been removed and what has been added. And for what has been renamed, or at least what is intended to be renamed, we take the struct annotation, right? We take the struct annotation, old name, new name, and we use that, right? So we can just say, okay, the developer is now renaming this field, and we can create a new field with that name and just copy the data into it, right? Or at least we can add the query to do that. So this query is going to take the new field and copy the data into it. All right, that can be included in the query. Since SurrealDB doesn't support alter statements yet, when it does, we can do that. Then what else? So we detect change, removal, and addition, and I believe those are the main things. So once we accumulate all these removal statements, addition statement, and change statement, we can then take that and put it in the new up. We put it in the new up query, or up migration rather. And one thing we also have to do, when we're getting the up, we have to get the equivalent of down. So when there's an addition, we have to also have a down, corresponding down statement that would be unsetting that field or removing that field. When there's a remover, we need to have a corresponding addition. So when you remove a field, then we need to detect from the existing table what was the statement that was there for the field, so that we can put that in the down migration. So that would be like, if you roll down, then you should have the field definition, and for the new up, it would be the removal. And when there is a change also, we get the left and the right. The left would be what is in the database currently and what is in our code base, right? So what is in the database from the migration file, the old, like until we apply this new one, would be the left, and what is in our code base would be the right. If there is a diff or there's any change, we add that to the new up, and we add the old statement to the down, right? So that's what we're gonna do. That might require a little bit of logic actually. So I'm contemplating on taking a short break. but let me see what we can still achieve. We have this file change. Where was get from there? Get all migrations from there. Okay. Now we want to migration names from there within there. I believe what's the way we can club and get all the names so that we can read all the up migrations. Let's just use now. Okay, get all migrations, then there can be get all up migrations also. This could probably be methods of that. Yeah, I think I'm gonna take a break from here and I'll continue.